Thank you, Bernd. Okay, we started today with 5G convergence, and we'll be back on that. So I will talk a little about what will happen in the world of opportunities within MDU buildings and your home. Let's see, how does it work? I'm Helge Tiainen. Daily work is business development manager in a Swedish company called InCoax Networks. Then I have these evening hours spending with as a chair of MOCA Access Working Group, and also as a board member and active in a number of groups in BBF. The topic for today, as I mentioned, is technologies are converging, and I will focus a little bit on MOCA. MOCA is very well known as a home network technology in US, but as we saw, the technologies are going together and the services change. MOCA is also changing, and I will also touch down on another technology which is called G.hn. One of the reasons why this has come up is that when you as an operator want to deploy GPON into an existing MDU building, you get a lot of barriers. One is first that MDU owners don't want to have a new cabling in the building. They want no changes. We can see that this in some countries may be easier, but if you go to countries like Germany, where they have Hausfraus, for example, they say no change in our building, we are so used to this. So it's very difficult to reach these apartments with a GPON connections. I mean, FTTH is almost impossible in those buildings. Then of course you can use other technologies, which I will talk about. And then it takes time also. If you have a decision from a condo association, it can take a year before you get an approval. Everyone has to approve on this new infrastructure. And even if you get an approval that you can use the hallways, the public places for cabling, then you have the home. Homeowners usually have maybe bought the apartment, they're re-renting it, and they think, why do we need to do any cabling in my home? Why should you do that? And that can also take a lot of time. And if you finally have agreed an agreement with the installation company, then comes the big problem to deliver the keys. Because people are not home during daytime, they're home nighttime, and no installer is working nighttime. So this is something which can take sustainable long time, and it slows down the deployment of FTTH in MDU buildings. And we see that. If you look on the private home areas, it's much easier to do that because you have one buyer, you have one decision maker, instead of having multiple decision makers and also a building owner or association who has to agree on this. And also you come to the situation that who is going to decide whose service is going to be in the MDU? I mean, if you're an MDU owner, should I select operator, service provider 1, 2, 3, 4, or 5 on the behalf of the people who are living there? And there is not so many good technologies really to have a wholesale model where the people who live in the apartments can select the services. So there are a number of barriers to really deploy something new. And even if you have deployed something, there is always the problem who will have the rights to deliver the services. And of course, if you don't be able to deploy fiber into the building or FTTH to the building, then you have to use the existing infrastructure. And there is in principle two infrastructures. One is the phone wires, which is the G-fast way, VDSL way, ADSL way. And the other one, which is not so known among telecom people, is the old bloody Coax, which is there, which the cable operators has used. And if you look on these two medias, the Coax cable is really, outperforming the copper cable. It has usually a much shorter age because we have gone from an analog TV to digital TV, so many of these cables has been refurbished. For example, in UK, when they went over from analog TV to digital TV a few years ago, 50% of the MDU cables were replaced to new systems. So they are really fresh. They are in principle a new type of virtual fiber. And this cable, this coax cable, reaches in the heart of the home. If you think of taking in a fiber, you usually come to the entrance door, and then you have to build a local area network within the home. In this case, you come typically into the heart of the living room or a heart of the bedroom. And also another thing which is important, that Coax is something which is revitalization. We can see, for example, AT&T's decision to run G-Fast in here in US. It is not over copper cable, it is over Coax. And the reason is that you have a possibility to support multi-gigabit in future. And there has been made calculations that the Coax can even provide up to 25 gig. So there is only a question of what type of radio technology I get to deliver these services. So there are a number of technologies, as I mentioned, G-Fast, there is the profile which is 212 megahertz, there is a new version coming which is 424. This is a technology which is very well, I mean, it works very well over the coax structure, but the problem is that it requires a point-to-point connection. And I will explain that later. That means you have one customer on each of the nodes connected. And in many buildings, there is not that type of coax structure available. There is a point-to-multipoint, and that makes the story much more difficult. Then we have G.hn, which is a home network technology. And here comes the convergence picture in. It started as a home network technology for coax, for phone wires, for, power lines. And its success today seems to be it's working much more better as an access technology. We had a BBF event in Seoul where Korean Telecom showed, here we are using G.hn instead of G.fast with almost a better performance than G.fast and much cheaper. So that's an example that home network technology can be used also as an access to the home. We have MOCA access. MOCA has been around for a number of years as a home network technology. There is the same trend that MOCA becomes an access technology. And when you become an access technology, you will probably combine these both functions. MOCA has been used as a mesh network within the home. And there are a number of operators using this in US today. There is very many delivered equipments out there, so it's in use, in big use today. But with a new type of services, we get more and more of our services up in the cloud, so why not combine those? Why not make the access combined with the home? Because you're using, in principle, the same wires. Of course, there are a number of challenges if you are not physically separated, but that are questions like we are working in a MOCA access or MOCA community now. How can we combine these technologies? How can we make access and home as a one technology? Or as we call it in BBF, where we have a work going on, which is VT419, which is fiber access extension. How can we extend the fiber with the same services, totally transparent up to the apartment, so the subscriber don't see any difference. They see, here it is, once I get it from my ONT, the service, now I get it from my coax outlet. But it's exactly the same services. And that's the beauty of coax. So a little bit about MOCA. MOCA has been there since 2005. It started to be rather old technology. We introduced the MOCA 1 in 2007. We had the MOCA 2.0 field trials in 2015. And in 2017, we announced the MOCA Access 2.5 specification. And last summer, we had already the MOCA 3.0 home specification ready. But now comes the convergence. Now we are working on how to build the convergence, because these two technologies will be converged, because that will deliver the most efficient and most serviceable solution. Because homing before was not manageable. Today you want to manage everything, and that is what MOCA can provide. It can provide the whole way. And a little bit of the overview. Alliance was established in 2004. And it's recognized as a very reliable network technology. In the early days, it was not manageable. That makes it, of course, people didn't like it. Today, it is fully manageable. So you can see every parameter on the radio link. It is like in the mobile world, our 5G fixed line technology. Makes in principle the same things. There has been shipped more than 270 million chipsets, so it's, I guess everyone you have a device which is MOCA enabled today. And it's very much in US because we have the private homes. In US we have only 20 million apartments in MDU buildings, while in Europe it is about 230 million. And of course in an MDU department, if you have a single unit, then you don't need a home network. But in a large American home you can have many outlets, and then MOCA is a very suitable technology. So, a little bit about the features. This is a MAC-PHY. I don't want to go too deep into it because I see our time is very stretched. But it is a MAC-PHY specification, which means that it acts as an PHY device which can be connected to any type of, MPU or switch or some FPA. So, and it is supporting today 2.5 gig physical speed of the line. So it is a very efficient way. So that can provide both symmetrical services. It can provide guaranteed services for business customers. So it's both a residential and business solution, and it has a low latency. We are today on a round-trip latency of 6 milliseconds, and in the new generations we are looking on ultra-low latency, which means we can come down to around 1.5 milliseconds. So, principle is, this is nothing more difficult. It's not any magic. You have a host, you have a chipset from a chipset vendor, which provides a link capability of about 250 meters. That makes about 800 feet. And you can run, depending on how much frequency space you have, you can run up to 2.5 gig. It's configurable, because the beauty of this is it can coexist with some existing services. It can even coexist with DOCSIS services, because it's using the free spectrum. And it is built as an what we call TR-181 data model for fitting into a BBF environment. And if you look on the Coax topologies in US, it is typically point-to-point, which is the left one called star. That means you reach each apartment from the basement and to the apartment. While when you come to Europe, you have something which is called cascade. You have 4 loops, but they are connected on the same wire. And then you have to have a technology which separates the customer and guarantee that each customer gets the speed they want to have or they have ordered, and especially business customers. And then you have the tap network, which means that you have only one trunk. So this is a little bit of network planning. What is the capacity you can offer depending on the structure, but in principle you can build a network that can provide gigabit services to any customer. And in the work, which we, as I mentioned, the VT419, we have defined a new definition which we call fiber to the extension point. This is due to that we have to define which points you can take the GFast installation point, the G.hn installation point, or the MOCA access installation point. And these can be either out in the cabinet, on the wall of the building, in the basement, on the floor, or on the top of the building, depending on where the coax network is initiating. And this work is ongoing. I hope that it's ready sometime beginning next year. And if you look on one thing which has been very popular to discuss is the reverse power feed. Especially in US, we have to think of reverse power feed because of FCC regulations. And with a coax installation, there is already standards in place that you can use reverse power feed, because satellite dishes are powered over the coax. So there are ready components which can feed reverse power feed. Typically they supply 25 volt, 1 ampere. So the device, the outdoor cabinet, the DPU or the central node can be powered from the different outlets with existing technology though. We don't need to define a new standard or so. If you go to a reverse power feed with individual powering, if you have a line up to each of the apartment, then of course we can have individual RFP also. So for cable operators, they can use power over coax because they typically have power over coax to their different amplifier nodes, and that can be used to power the central node. And how does this type of boxes look? They are like small devices like this size. This is a 10 gig uplink and 4 ports on the southbound part. And it can be connected to an XGS PON or PON network or GPON network. So it is that type of box. It's not complicated. So we come to the question panel, I guess.
Excellent. Perfect. Thanks a lot, Helge. You can actually sit down here.